Okay. So this is the third lecture of the Teachers as Scholars. And so what I want to do now is I want to move to the pirate game. So this, yes, and I will switch that in just a second. Okay. It should be on actually. Maybe the TV just turned off because it's been so long. Okay. There we go. Okay, excellent. So it's compressed it a little bit, but it's not too bad. Okay. All right, so this is a great game. And so here's how it works. We have 5 pirates. I have no idea why it's doing so super thick. No, we don't want to start. We might have to go down like this. Thank you. It's not touching. Not touching. Okay. So we have 5 pirates named 1, 2, 3, 4, 5. Lowest named pirate proposes a division of 100 coins. If at least 50% approve, do and done. Else proposer walks plank and dies. Continue with next lowest. And we just keep cycling like this. So you have 5 pirates. You have 100 gold coins to distribute. The first pirate proposes how to divide the 100 coins among the 5 people. If at least 50% agree with that proposal, you do that proposal. If not, that pirate is killed. And then the next lowest named pirate makes a proposal. If that's accepted, you do it, else that pirate is killed. Has anybody seen this riddle, this game before? Okay, good. So the question is, how would you analyze something like this? And I am not sure why the color has changed and it's no longer the dark colors.
How do you ask?
I'm sorry?
Like, do the 2, 3, 4, and 5 huddle and decide?
So good.
Or just 2
So
say
excellent,
no,
excellent, excellent. The analysis depends completely on how things are done. And so this is one of the things I love is we all make assumptions when we hear things. I remember at Williams, we have an award for which senior has gone to the most math public talks. And whoever goes to the most wins a prize. And we decided a few years ago to allow people to go up to 5 talks that will count as a junior. And the question was, should that count towards the attendance award for most talks gone to by a senior? And it was decided that this was obvious. And then I raised my hand, obvious which way? And it turned out half the department thought it was obvious one way, and half the department thought it was obvious the other way, but everybody thought it was obvious. And so when you have something, you want to be clear. So how are people discussing? So whoever proposes, they make the proposal in public. Do people vote publicly or privately? So let's say it's public voting.
Do they vote one at a time?
All at once.
Okay.
And so exactly, you say, do they vote one at a time? Because you could change your vote based on what's going on before you. So everybody has to vote at the same time. Can you promise to vote a certain way and then vote another way? Or if you tell someone, I'm going to vote, if you publicly say before the vote happens, I'm going to vote for this, can you change your mind at the last minute? Or are you locked into what you said publicly?
So what happens if they accept?
Then you just divide the money as was proposed.
It's done.
It's done. So as soon as something gets at least 50%, It would be different if you said majority, because with an odd number of people, the initial proposal needs 3 votes. But if there's only 4 people, now 2 votes would be enough rather than 3 votes. It does change if you're doing 50% or more than 50%. And so we have to be very careful. We were talking a little bit before about how easy it is to have stereotypes. And most stereotypes are bad, but pirates are not a protected category. So we are allowed to assume pirates are cutthroat, murderous scum who are untrustworthy. So just because a pirate says they're going to vote with you does not mean you can trust that when the vote happens. So it's not like they can write down and then they are locked into their vote. They can change their mind at the last minute. Is it immediately clear what the answer is to this problem, as to what strategy the pirates should adopt?
In order to divide the money, you mean?
Well, so each pirate has a strategy,
Okay.
right?
To get the most. To get the most money.
The most money that they can.
To not die.
Well,
To not die.
so it's not even clear what your strategy is.
Number 5 is never gonna agree to anything.
I'm sorry?
Number 5 should never agree to anything. Exactly.
Well, not necessarily. Why should number 5 never agree to anything?
Well, because then everybody could just die, and they get all the money.
Okay, so rather than analyzing the case with 5 pirates,
Maybe alone.
Except
what's
if it's at least 50% approved, if you're at 4 and 5, and 4 says something, they approve, 5 doesn't.
Oh,
so good. So what you are doing is
4 that you wanna be.
you're making it seem like I might have actually done a good job earlier today by trying to break this into smaller into easier cases. Break into easier cases. What's the easiest case to analyze? 1 pirate. So 1 pirate, what's the proposal? I get all. And it's accepted. What if there's 2 pirates? So this would be just, 5 pirates. 4 and 5 pirates. What happens here?
4, can you get it all?
So,
5 gets nothing.
so somehow I think it had an extreme zoom in. Okay. That's why the text was looking different. Okay, break into cases. So 5 pirate, I get all. And that's accepted. 4 and 5 pirates, 4 gets all, 5 gets nothing. And that's accepted because it has 50%. Okay, so now the first interesting case is when we have pirates 3, 4, and 5. And pirate 3 has to propose. What should pirate 3 propose?
If he doesn't wanna die?
I'm just asking what I'm not saying anything other than what should pirate 3 propose?
The majority of the money to go to 4 and 5.
Why should pirate 3 propose that?
He only needs 1 ally.
Oh, that's true.
So what were you thinking?
Oh, I
Mary?
think of that.
Sorry, I just wanted to clarify,
Yeah.
so is it 100, or does the money go back every round, or is it once they collect the money, there's no money?
Well, once they collect the money, the game's over.
So we should do a
so
50-50 split.
as soon as the division is accepted, we're done.
Oh, okay, I see.
So
I
it's-
wasn't sure it was like round 1. I was
No.
thinking-
As soon as a proposal is accepted. So if there's just 1 pirate, that 1 pirate gets everything. If there's just 2 pirates, then the lower numbered pirate gets everything. If there are 3 pirates, what should pirate 3 propose?
Wants to split it with someone,
Yeah,
one
split it
other
with
person.
Who should 3 look for
5.
allies? Why not 4?
Because if he dies, 4 gets it all.
So does 4 have any incentive to work with 3,
No.
right?
So couldn't 3 go 99-1?
So 3 proposes 99-0-1. Do you think pirate 4 will vote for this? No. Pirate 5.
Take 1/0.
Take 1/0. So does everybody agree that Pirate 5 will like this proposal?
Like,
Well, it's
better than what you
it's
get.
better than 0, so I'd call that a like. Could Pirate 3 propose 1 coin goes to Pirate 4? Pirate 4 knows that if she doesn't say yes, she gets nothing. Because he could make the proposal to Pirate 5. But when they come to vote, can Pirate 3 trust Pirate 4 to support? So I think it's really risky for Pirate 3 to try to do something with Pirate 4. Because Pirate 4, you can say, hey, 4, let's screw Pirate 5. Okay, I'm with you. And then Pirate 4 screws Pirate 3 and then takes everything. So I think this would have a yes, no, yes, and it's accepted. Do we agree? So let's keep moving backwards. So again, this is the general theme. There's supposed to be a couple of just key ideas you can take out of these teachers as scholars. Reduce something complicated to simpler things and build up. So reduce to simpler and build up. So now we have 2, 3, 4, and 5 pirates. What should 2 propose?
I'll give $1 to 4 and take everything else for myself.
So 99,010. So I think we can assume that Pirate 3 doesn't like this proposal. Because what happens if this proposal is rejected? He gets more money. So Pirate 3 is definitely going to be a no. What about Pirate 4?
They get something.
They get something. And if this proposal fails, what will Pirate 4 get? 0. So Pirate 4 is going to vote yes. What about Pirate 5?
No.
No. Doesn't matter. We got 50%. It's accepted. So now we have 1, 2, 3, 4, 5 pirates. What does 1 propose? So what would Pirate 1 propose now?
Be 98 for themselves.
98 for themselves.
0 for 2.
Yep.
1 for 3.
Yep.
0 for 4.
Yep.
1 for 5.
Yep. And so if this proposal fails, Pirates 2 and 4 will get money. Pirates 3 and 5 will get nothing. So Pirates 3 and 5 are getting something here. So this is going to be yes, no, yes, no, yes, and accepted. Is everybody comfortable with this?
Can you explain to me again the order, like why, like, for example, why are we giving, I understand to get 2 votes, you would split it 98 and
Right.
then the 2 remainder, but why 0, 1, 0, 1 again? Like, why not
So
2 and 3?
you want to do this with 5 people?
I mean, any.
Okay, so let's do it with 5. So what would be a proposal you would want us to analyze?
I'm just saying, for example, why not Pirates 2 and 3, they each get $1.
Like this?
Yeah,
So let's say we have this. Do you think Pirates 4 and 5 will support this? They're getting nothing.
right.
So Pirates 4 and 5 know that they can't get worse if the game continues. They may not get better, but they can't get worse. So Pirates 4 and 5 won't support this. Pirate 3, well, I get 1, and if this fails, we go to the case of 4 pirates, in which case I'm going to get 0. So I'll support that. Pirate 2, they're getting 1. That seems good, right? But if Pirate 2 says, I'm going to support this proposal, and then when they all say their votes at the same time says no, this proposal is then killed, Pirate 1 is removed, And now you go to just 4 pirates, pirates 2, 3, 4, 5, and now pirate 2 can get 99. So the problem is, this is a way to distribute 2 coins among 2 pirates to try to buy their votes, but you can't trust pirate 2. Even though they're getting something, they know they'll get more if they screw you. They have an incentive to screw you.
But what about 4 and 5? Like, is there a reason? Like, I get that if it's voted down, then the next situation, pirate 4 gets 1 as opposed to nothing. But like,
But-
why wouldn't 98, 0, 1, 1, 0 work too?
Okay, so you want to try 98, 0, 1, 1.
0, yeah.
So this is interesting. So if you tried this, pirate 3 will vote with you.
Right.
Pirate 2 will vote against you.
Right.
Pirate 5 is going to vote against.
Yeah.
Because they can't do worse.
Right.
Pirate 4 is in an interesting place where they might be indifferent to this. Because either they get one thing here, or if they vote no, then it goes down to 4 pirates, and they'll also be getting
Okay.
1.
So it just comes down to whether they like pirate 1.
So it comes down to, do they like pirate 1, or are they willing to take a chance that maybe pirate 2 might mispropose? Maybe they'll give them a little bit more, but if they mispropose, then you could get into the situation where there's 3 pirates and they get none.
Right.
So I would say that this is a possibility. It's not a guarantee, but if you look at this from Pirates 4 perspective, they don't really expect to be able to do better, and they might do worse.
Right.
So you might be able to get, I think the cleanest is 980101. I think that's the cleanest. I think that's a possible. Does anybody notice any patterns emerging? What do you notice?
Well, 100 minus however many ones you have.
Okay,
0, 1, 0, 1, 0, 1, 0.
and so how are the pirates splitting?
Alternate.
Odds and evens. In alliance. So really, all the odds are in some sense on the same team, and all the evens are on the same team. So this goes back to the Fibonacci's at the start of the day, that you're looking at patterns, odds and evens. We have a similar pattern here, that all the odd-numbered pirates are somewhat together. So is everybody happy with this analysis?
Well, doesn't prove what's gonna happen next.
Well, I mean, we should be able to continue this pattern if we had more and more pirates.
Provided all your pirates know something about math and game theory. They're well-educated pirates and logical pirates.
So this is where things get interesting. And this is where some of you have expressed the desire to have things that relate to the real world.
Psychologists involved here.
You have to be extremely careful talking about politics with any group. So I will try to do things as generically as possible. If you are negotiating with someone and trying to decide on an amount, do you want to speak first or second?
Second.
Second, why?
So that's like closing on a house, right? So typically there's an amount that you're presenting, but
Right.
you go low,
Right.
they respond back, and then you need to know, you wanna shoot low, you don't wanna overcompensate.
Right.
You wanna do it more than you want.
Let's say you're willing to do a job for $200 an hour. And you also say, I'm willing to do it for $200 an hour. You're not going to have the other side say, well, we want to give you $300 an hour. You've just assured that your maximum is 200. What if they say, if they open, we'll give you $300 an hour to do this? You're jumping for joy. I would have done it for 2. Well, I'm really busy right now. I was kind of hoping for at least $500 an hour for this. And so if the other side goes first, you're in a much better negotiating position. So you do not want to be the first mover in something like this. So over here, you're trying to get to real world situations. What kind of pirates are we talking about? So there was some mention about maybe logical pirates. Let's analyze one of the cases in a little bit more detail. Let's look at 3 pirates. So we have pirates 3, 4, and 5, and 3 proposals. And we said they should do 99, 0, and 1. Are you going to get pirate 4's vote? No. Are you going to get pirate 3's vote? Yes. What about pirate 5? Is pirate 5 going to vote for this?
Yes.
What happens if pirate 5 doesn't vote for this? Gets 0. So pirate 5 should say yes, else they get 0. But if they say no, what happens?
Do they get killed? Does the fifth?
The proposer gets
the
killed,
proposer get-
then pirate 3 dies. So pirate 3 makes this offer. Pirate 5 knows that, if they don't accept this offer, they get nothing. But they also know if they don't accept this offer, pirate 1 dies. What should pirate 5 say to pirate 3 as the negotiation ensues? Give me more money. So 3, so let's see, 5 suggests to 3 what distribution? How much should go to pirate 4? No, pirate 4.
Oh, 4, nothing.
Nothing, right? We're not going to get pirate 4's vote because if this is voted down, pirate 4 gets everything. So pirate 3 was just saying informally, I'm going to keep 99 and I'm going to give you 1. What do you think pirate 5 should counter with?
Okay, how much is your life worth?
So what'd you say?
Moving around.
So one possibility is the almost full extreme. There is a more extreme flip.
0, 0, 100.
You could actually do real brinkmanship and say 0, 0, 100. You give me everything or you die. And then you have to worry about, sometimes if I'm going to go down, I'm going to take you with me. And okay, yeah, but you'll get nothing.
At that point, can pirate 4 say, how about I take 99, pirate 3 takes 1, and pirate 5 doesn't get anything?
You could, but then pirate 3 would have to trust pirate 4.
That's true.
Yeah.
And so when you're all voting at the same time, pirate 4 can, now it would be very different if you had to write down your vote, put it in the middle, and then you can change it until everybody agrees that this is my final vote. And as soon as one person says it's not my final vote, everybody, then that would change the game completely.
In one of my classes, whenever I have spare time, I do like the mathematics of trust.
Yes.
And my question would be, what are the repeated interactions with these pirates?
And so,
Or are they meeting
so
for
it's
the first
extremely
time?
important that this is a non-repeated game. It's a one-time game.
And they've never met each other?
Well, they've been plundering the 7 seas. Extra credit for anybody who knows what movie has the pirate ship Revenge. Captained by the Dread Pirate Roberts.
Oh, yeah, well, Princess Bride.
Princess Bride, thank you. Great movie. So what do you think what kind of response do you think 5's proposal would get?
The proposals.
So 5 said either said 1099 or 00 either one of those. What do you think pirate 3 will do?
I swear on your life, you're not gonna deceive me, I don't know.
Well, the thing is,
How can you trust that, it's like, what's in?
Plundering for a long time. Is he the type of person who will actually kill them?
well, I mean, the thing is, pirate 3 knows that if this is voted down, pirate 4 gets everything and pirate 1 gets nothing. So what can pirate 3, does pirate 3 accept this or does pirate 3 make a counter proposal?
Counter.
All right, so what do you think pirate 3 would counter with? So,
We
so,
gotta meet in the middle.
so that's not a bad idea. 3 counters with, 50, 0, 50. Let's screw pirate 4. And this is where things get really interesting. What do you think pirate 5 does?
Pretty tough to say no to, because you're leaving 0 or 50, pretty big gap.
So if you're pirate 5, this is giving you half the amount. There's only 3 people, so if you divided it evenly, you should be getting around 33, so you're getting more than half. Does this seem reasonable? But what could pirate, so 5 could say yes.
Does the person who's proposing it get to vote or no?
Yep, they get to vote.
Oh,
So-
it all comes down to 5, because who cares what 4 votes, because
It all comes down to 5.
it says 5.
Portion of vote regardless.
4 is all 4, you're never gonna get 4.
But even if 4 votes yes, then who cares, it's just.
Well, 4 votes yes, then you can lose 5. But you can't trust 4 to vote your way. So 5 could say yes and say, look, this seems pretty fair. We split the plunder between the 2 of us. I'm getting more than I should have. What could, however, 5 counter with?
Want it all.
I want it all. 5 could still counter with 0, 0, 100. You give me everything or you die. And then 1 could counter back, and then 3 could counter, could say yes, or counter. One way would be you could reiterate the 50, 0, 50, or you could do the 99, 0, 1. You know what? You've pissed me off. Forget it. There's no right or wrong answer here. This now depends on the dynamics of the players and the psychology. And so when you're trying to analyze situations, and you're again trying to do this without using real world political examples, because this is dangerous, you do not want to be too predictable. If people know exactly what you're going to do, they can then plan accordingly. How many times do you have somebody making strange public announcements? Oh my God, yeah, we're trying so hard to control them. They're crazy, they could do anything. And a lot of times you get much better deals by having people not sure what you mean or not. And so you deliberately take strange, absurd positions. The mutually assured destruction in the Cold War, both sides did not want a nuclear war. Both sides were rational and knew you're not going to win a nuclear war, at least not after the first couple of years, once each side had so many weapons. But with a small terrorist state, it's not clear that they would be averse to having a nuclear war. And so the negotiations become far more complex. So when you're trying to come up with an example to talk to students, I just did the analysis, the standard, break it up into a simpler case, build up from that, and gave you a very natural argument that you guys created, that we will get to this division of the evens and the odds and alliance, and whoever proposes gets almost all of the money. But if you start putting in real world negotiating stuff, it becomes very different. And a lot of it is, do you trust the other person?
sorry,
Yeah, no.
this reminds me of 2 shows. One, Squid Game,
Okay.
and 2, I don't know if anyone watches The Traders, but it's
Oh,
kind of
wow.
like that too, where they have to form alliances and kind of deceive each other,
Yes.
and it's like there's people from like the gamers,
Yeah.
you know, and they strategize on this, how to get votes,
Right.
and how to kick people out. Like I just see it similar.
Well, the Hunger Games is we're going to
Yeah.
be an alliance until one of us has to not kill the other. And when is the right moment to turn on your allies?
Survivor issue, it's like all that.
Yeah.
Very similar.
And so, just trying to find ways to connect with students. How do you analyze something like this? What features do you want to put in? So if you want to do math in the real world, you don't just have these completely rational, passionless entities. How much are you willing to bluff and how much are you willing to risk losing? Do you call someone's bluff if you play a 3? If you're wrong, you die. But player 5 then gets nothing. How much is player 5 really willing to do it when it comes down to, I have to vote yes or no? And so a lot of times you're willing to make a public posture, but at the end of the day, well, I know that so a lot of the Cold War mutually assured destruction strategy was to convince the other side that if you launch a nuclear strike, we're going to launch one back. Whether or not you would actually do that in the situation is unclear. Thankfully, we do not know the answer to that. But you need the other side to believe that you would push the button.
I was gonna ask, is there any scenario where you would be able to even get like if they lowered it and they said, I get 40, you get 60, like give them the majority?
Give who the majority?
The player 5, player 5.
Yeah,
right?
player
So
5.
player 3 is like, all right, like basically like gives him a little bit. It was like, I take 40, you take 60.
Right.
Would there ever be a play like that? Because couldn't they always just counteroffer? And if you ever accepted it, if you went down, if you're like
So again,
35 to 65, like it would just
So
constantly go down to that.
it comes down to the personalities and how serious they are on the threat. Pirate 5's big weapon is that if I don't vote yes, you die. And Pirate 3's big response is, if you don't vote yes, you get nothing. And so I'm a huge believer in enlightened self-interest. Altruism, no. Enlightened self-interest, yes. It is in the interest of both people to accept a large number of these options. But when you finally go to vote, player 3 can just say, look, do what you want. I'm making you the proposal 9901. If you want to screw me, screw me. You'll get nothing. And then this is why sometimes you have situations where you deliberately do things and you make it irrevocable so that you can't be swayed anymore. So
Wonder if that, how like they vote for the Pope, like multiple votes and stuff. I wonder if you could say, well, they can have up to 5 votes or something, so they can use the information from the
Right.
before.
now that would be fascinating, is so that's a great twist on this game. What would happen if you could vote twice? If player 3 can make 2 proposals before they die?
And if the order matters, like would you do both or could you do one before the other?
So no one's ever asked this question. I think it's a great question. I don't care if the rest of you are interested, I'm interested. 2 proposals. Similar to Mel Brooks, It's Good to Be the King.
Yeah.
So 2 proposals. So now we have 3, 4, 5. What should 3 propose? I have a thought as to what I would propose if I was 3.
So wait, what are the rules? They're 3 gonna propose
three-
something, they're gonna vote, and then they're gonna propose
And then
again.
propose, right, so if the first proposal passes, the game is over.
But they
If it
still get a second
fails,
chance.
you get a second chance. I have a thought as to what I would propose if I was 3.
I do this.
And that's where I thought before around.
Would it make sense for him, if he gets a second chance, I would, I would say I get all and you get none.
Except for 1. 99 on 1.
So which proposal would you make?
I would think if I said I want all, the other 2 would vote against that.
Right, so that's so is that a wasted proposal?
But if you get a second chance,
But should you start, should he do the 50-50 proposal and let him turn that down and then be like, all right, well, if you want anything, then I'm gonna do the 98-1?
So you could start off with the 50-0-50,
I was thinking the other way around.
right? You could start off with the 50-0-50 and say, look, you can accept this, we each get 50. And if you don't, then I'm telling you my next proposal is going to be 99-0-1. And what player 5 could say, however, is bull. Oh, wait, this is being recorded on YouTube. Bull. I don't believe you have the guts to propose 99-0-1. So I'm going to vote no on this proposal. Or they might say, maybe you are. Any other proposals?
Start with the 99-0-1.
So that's one possibility. Or start 99-0-1. So if you start 99-0-1, what happens if player 5 says no?
At that point, I would say they can have it all. I want to live.
Well, then it's saying that the next proposal.
Has to
Yeah,
be
more.
accepted, right?
Yeah. You should start with the 50, that makes more sense.
I think it's another interesting proposal. Does anybody have another thought? I'm thinking outside the box.
You thinking give 4 something?
I'm thinking give 4 something. I would say start 9910. And tell player 4, I'm gonna give you 1. If you vote against me,
You get
He
nothing.
gave nothing.
I only have 1 proposal left, and I have to then give basically everything to 5 in order to assure that I'm alive.
Yeah, but 4 doesn't care.
But 4 is now getting
4
something.
cares.
4 is now getting something. What if 4 plays hardball and says, I want more than 1? So you can say, I can play this game with 5.
Yeah, 4 doesn't have any power.
4 has some power. If 4 gets greedy, then we're gonna get into the next situation where the next proposal 3 makes has to be accepted. What if 4 counters, say 90-10-0? Would you accept that as 3?
No. Because if 3 dies, then 4 gets everything. So 4 says, I'll counter, but still will vote no.
But if they vote no, oh, sorry, this is discussion, sorry. And no proposal formally made yet. In discussion. So you 3 say, what if I do 99-10? And 4 just politely says, how about 90-10-0? You haven't made any proposal yet. This is a straw poll. If you were 3, would you take 90-10-0?
It's not gonna pass.
Well, if you have your vote and 4's vote, it passes.
Why would 4 take 10 when 4 knows that if 3 dies, 4 gets everything?
Because 3 still has 1 proposal left.
They
Well,
can-
that's the first proposal.
This is the first proposal.
Oh,
Nothing is,
sorry.
no proposal has been formally made yet in discussion. So this is like a straw poll.
Sorry, I thought that was the second one.
Nope, sorry, straw poll. So they're just talking amongst themselves. Would you accept this if you were pirate 3? Or would you risk and you have only 1 proposal left and now 5 can have you killed?
I think it depends on the risk tolerance, but I would assume 90 would be, I mean, how much am I willing to risk my life for 10 points?
Right, I think 90 is high enough that if I was pirate 3 and pirate 4 is only asking for 10, I think I would do it.
What happens if you do that and they trick you to get rid of your proposal and say no?
Well, then if they do that, then you'll have only 1 proposal left and 4 knows they're getting nothing. And now you can negotiate with 4 where all you're risking now is potentially money rather than money and your life. Because you still have 1 proposal left. Could 4 go all the way up to saying 50-50? I think 4 might even be able to get to 50-50. Just as you're talking amongst yourselves to say, look, if I'm pirate 3 and I don't win on this round, I only have 1 proposal left. I have no space for any no mistakes. So do people like the 90-10-0? I think 90-10-0 would probably pass. The question is, how far can 4 push it?
Right.
I think 4 could probably push it to 50-50. Maybe 4 could get 50-50-0, because if 4 screws 3, 3 can always just give everything to 5. And if 5 votes against it, then 5 gets nothing.
Why can't four say then, I think you should propose 199.0.
So that becomes an interesting, so what if 4 says make first proposal 199.0?
I think if that happens, I go back, now it kind of restarts and I go back to the original problem we had with 5. And now do I want to take the risk of 1 coin versus 99? And I would probably take that risk of 5.
And so 3 can come back to 4 and say, look, if you do this, I'm going to make an alliance with 5. And I may go from 1 to 0, but you're going to go from 99 to 0. And so I don't think there's a clear answer as to what is the right. A lot of it comes down to bluffing. And so you can't analyze a game like poker without including bluffing. And so you have to take into the psychology of the players. This is one of the reasons I love this game. It's not clear what the right answer is. That's fine. A lot of it is just having the discussion with the kids. What strategies would you adopt? How would you try to analyze this? How would you adjust based on what's going on? And a lot of it is, and this is a skill that you need in the real world, is you need the ability to bluff. And you have to be able to do it convincingly.
Is there a way to add into this? I know when I do the like the math of trust lesson, they add in the possibility of mistakes, things like that. Like, oh, there's like a 10% chance or 2% chance that they either write down the wrong pirate or like mistakes happen type of thing.
You could do something like that where maybe
Now it kind of throws in a wrench of
yep.
the risk.
You can always throw in more, and the more things you throw in, the harder it is. I love this idea of multiple rounds of proposal. And as you have more and more proposals, you can afford to be, would it be different if you had 3 proposals or 4 proposals? And so based on this, if people are willing, if people like games, I'll switch to the egg drop game. So let me stop the recording. We'll take like a 5-minute break.
What's the math?
It's basically a version